I think the single most common issue that people run into when working with NoSQL databases like Firestore is joining relational data. The simple fact is that there just isn't a join clause in document-oriented databases like there are in SQL databases. And if you're not already familiar with joins, it's when you have two collections or tables and you join them together on a common key. We're going to simulate a variety of different joins using custom RxJS operators in this video. And we'll also make sure that every piece of data we retrieve will still react to real-time updates. The first one we'll do is a document-to-document join, which doesn't really have a SQL equivalent. This will allow you to save document IDs on one document, then join the information from all the related documents into a single unified object. This is the easiest one to implement, and it's useful when you have multiple has-one relationships. Maybe a user has a settings document and a country that they belong to, and you just want to unify all this information in a single real-time object. Then the next one we'll look at is how to join multiple collections together, similar to a left outer join in a SQL database. So you can see here that the user document and the order document have a common key value pair, user ID equals Jeff. Then we can query all the users in the database, we'll get all that user data, then we'll join every orders collection to that user document as long as it has the corresponding key value pair. Then we'll have one final operator that's kind of a combination between the two, which we'll discuss more at the very end of the video. Before we get into the code, I highly recommend you watch the custom RxJS operators video because we'll be using a lot of concepts that were discussed in more detail in that video. Let's start by joining multiple documents together. You can see here that I have an object that has a number of properties on it with additional sub-objects. The nested objects are actually related documents from completely different collections in Firestore. You can see here that the parent user document has references to these related documents by just saving their IDs as a string. So the data we're looking at right now has one parent object, and then it's joined three other related documents to it. And they all have real-time listeners that will react accordingly. So I just changed one of the document IDs on the parent document, and you can see it requeried it and updated it with the correct data. But the join documents are also real-time, which means we can go into this pets collection, edit the associated pet document, and that will also update on the join that we're looking at here in the UI. Now going into the code, I'm just going to write this out in its own TypeScript file. We'll import Angular Firestore. Then we have a couple things from RxJS. Make sure that you import combine latest from RxJS and not RxJS operators. Then we'll build our own custom operator called docJoin, which just starts out as a regular function. It will take the Angular Firestore instance as an argument because it doesn't have access to dependency injection or anything like that in Angular. Then we'll also be able to pass in an object where each key in that object is a key on the document that points to the collection where to find the related document. That'll make a little more sense once we actually show the usage of the operator in a few minutes. The next thing I'm doing is wrapping this operator inside of defer, so it only creates this stateful data that we're saving here on a per subscription basis. That's important if you have multiple subscribers and especially late subscribers coming to this observable. And we'll also set one for the path keys so we can use those among multiple operators. Then we'll return a pipe on the source observable. The first thing we'll retrieve is the data from the parent document, which we can do with switch map. Once we have the parent document, we'll have the IDs for the relational data that we want to retrieve. What we want to do is execute the reads on these related documents and then merge them together with the parent. So we'll save the parent as state on the operator for now by saying parent equals data. Then we'll map the keys that were passed in as the argument into the operator to the location of each document. Then we call Angular Firestore document value changes to convert it to an observable. So that gives us an array of observables, which we then pass in to combine latest. Combine latest will wait for all the document reads to complete and then emit them together in an array. Then the final step is to combine the parent document with the relational documents that we just read. This just takes a little bit of JavaScript gymnastics where we reduce the array of keys to a new object where the value of each key is now the actual data from that related document. And finally, we'll just compose a new object from the parent and the related documents and return that from our map function. And that's all there is to it. Let's go ahead and take a look at how this would be used in an actual component. So I'm just in the app component of my Angular app, and I'm making a reference to the user document with an ID of Jeff, and then getting it as an observable with value changes. Then I pipe in our custom operator and pass it Angular Firestore, plus an object where each key is the key with the relational data, and then the value is the collection where we can find that document. And if the document doesn't exist, then it will just map that value to null. So that gives you an easy way to join as many related documents together as you want. And just a quick side note, I'm unwrapping this observable in the HTML by looping over it with ng4 and the async pipe and the new key value pipe in Angular 6. That's how I'm showing each object property line by line like you see in the UI here. This next operator I gave a name of inner join, but I should have called it left join because it's more similar to that in SQL. It starts out exactly the same, but this time in the arguments, we're going to give it a field, which is a key value pair that needs to match between both documents. So that means you need to have a field like user ID equals Jeff that exists both on the user document and the order document. If either the key or the value is different, it won't work. You'll also notice that I've added a limit option that will limit the number of documents that get joined onto each object in the parent query. So if the parent query has 100 documents in it, and then each of those join another 100 documents, that'll be 10,000 document reads in total, so be careful with that. In fact, one of the cool things you can do with custom operators is implement your own logging system. And this operator will actually keep track of the size of the root query along with all of the joined documents. So in this case, we had queried 5 documents originally and then joined an additional 104 documents to that query, so 109 reads altogether. And again, that's possible by saving some stateful data on this operator, which we'll do with this total joins variable that starts off with 0. Then we'll create a pipe on the source observable and again start with switch map. So we're basically doing the same thing that we did in the previous operator, but the logic is just slightly different. Instead of querying a document, we're querying an entire collection. So we need to loop through each document in the original collection. Then we'll set up a query that only retrieves the documents that have the common key value pair between both collections. So the query will look for equality between the field that's passed in as the argument and then also the field that exists on the red document that's at this iteration in the loop. Then we'll go ahead and retrieve that as a collection and call value changes to get it as an observable, and then push it to the array of reads. If the field doesn't exist, then we'll just go ahead and push an empty observable of an array to it. And then just like we did before, we'll return combine latest from switch map. When we pipe in the map operator next, it gives us an array of the red documents from Firestore. So at this point, all the reads and queries are completed, and they're just set up as an array of arrays. As we map the queries to their parent documents, we'll go ahead and also increment our total joins so we know exactly how many docs were read from this query. And if you're worried about document reads, keep in mind it's only the initial query size you should really be worried about. If you have one document update, you'll only be charged for one additional document read. And that's just because of the way Firebase caches everything, so I'd really only worry about the initial size of the query and trying to limit the maximum amount of documents that can be queried by the way you set it up. To keep track of that for debugging, I'm piping in the tap operator and then just console logging the length of the initial query plus the total joins variable that we were keeping track of. Now, just to show you the usage of this in a component, it looks almost identical to the previous operator. It's actually even slightly more simple. So we originally query the users collection, and then we join everything in the orders collection that has a corresponding user ID that matches between both documents. If we go into the UI, you can see that each of our users now has an orders property that's either an empty array if they don't have any orders, or it's all of the orders that we queried based on the parameters that we passed in. So you can see Doug has one order, and then Sally has a whole bunch of orders in this array. I haven't done a whole lot of benchmarking with performance, but it really depends on the data payload that you're sending over the network. Sending a couple hundred small documents shouldn't be too bad, but if your documents are getting really large in size, this could get bogged down if you have a lot of documents in the join query. In order for this to work, we have to have a common key value pair between both documents. So for example, on an order document, I should have a user ID of Bubba. Then also on Bubba's user document, we have to have that same key value pair of user ID and Bubba. Then we have a real-time listener on this joined query, so if we add another document to Bubba's orders, it will update in real time in the UI. It's actually not very inefficient to add all these real-time listeners in the UI, it's more about the data payload that you're presenting. In the future, we'll probably see a lot of these operators implemented by default in libraries like RxFire and AngularFire 2, but a lot of times you just need to implement your own business logic because things can get pretty complex in a real-world app. I'm going to go ahead and wrap the video up there. Hopefully this gets you started on the right path for doing advanced stuff with RxJS and Firebase. If you have any questions, drop me a line on Slack. Thanks for being a pro member, and I'll talk to you soon.